Thank you. Thank you, Richard. Richard's not going to hear the end of this. So I would have to say kudos for all of you to come this early, especially with Los Angeles traffic. So I'm impressed. When Richard asked me to keynote, I said, what kind of topics are your audience going to be interested in? So we zeroed in on DevOps security and digital transformation. So I'm the founder and general partner of Rain Capital, which is a security-focused venture fund. So on my day-to-day job, I look at emerging tech and how they impact people's lives and impact enterprise computing. And one of the things I look at very closely is application security. And of course, these days, anytime you talk about application security, it has to be something that fits into DevOps. So DevOps security is something that I spend a lot of time on. Also, recently, I just became a member of the board of directors for a multi-billion-dollar utility company based in North Dakota. What's interesting is, thank you, Jimmy. So it is an interesting phase of my career because going from, I'm a technologist in training and recently has done sort of business and strategy, and then went from that to corporate governance is a shift. But this shift is interesting because I'm seeing more and more companies are looking for technologists and cybersecurity experts in particular to join corporate boards, and something to look forward to for all of you at some point in your career. Now, the reason I mention this is this company being in the utility sector is in a pretty traditional industry. Right? They run natural gas pipelines, they deliver electricity, and they also have one side of their business which is in construction. So they will lay down the pipeline or electricity for buildings and infrastructure projects. Because of that, their IT needs are very different than the high-tech companies that I'm used to, like Jimmy's company, Netflix. It's very different. The culture is also very different, but they also are super into the notion of digital transformation. And they want to understand and execute different projects that will put them in a competitive position for a long time to come. So because those different capacity, I'm looking at DevOps and digital transformation. And this presentation is really sort of the culmination of things that I've been looking at. And hopefully it will be interesting for all of you. What is that?
Somebody talking out.
Oh, I'm like, I didn't have. So one of the things I came across recently is some of the cutting-edge healthcare companies, what they're doing in digital transformation. Kaiser, for instance, has a project, a research project, I think, still at this stage, whereby today when a doctor or nurse walks into a patient's room, there's usually a chart, right? So they take the chart, they'll look at it, and they'll do some stuff, and they'll jot down information on the chart, and they'll hang it back up, and they'll do some stuff with the patient. Now somebody else walks in, and they look at the chart, and they can see everything. Now sometimes the person walks in the room is not a doctor or a nurse, or maybe it's an anesthesiologist who doesn't need to see everything. There is no way of controlling that information. There's also no way of controlling who's walking in the door because all the people walking in and out of the patient's room. So one of the projects that I've seen is interesting is using biometrics to authenticate who walks in the room in real time, and then have that connected to the back-end information infrastructure so that if it's indeed the doctor of the patient that walks in the room, he gets to see everything. They will display on the monitor in the room right away. Or if it's a nurse, maybe he or she gets to see limited information. The authentication is done in a way that does not impede the actual work. So doctors and nurses maybe walk in, they'll wear gloves. You cannot do fingerprinting authentication because you can't ask them to take off the gloves and touch something. And they typically don't want to do that. So it has to be a seamless authentication. So I've seen voice command, but the voice is like, hello, Mr. So-and-so, right? You walk in the room, you address the patient, and at that instant, they'll pick up the voice and will authenticate who that is. I've also seen facial and posture recognition. So there's a camera in the room and recognizes who you are, either by facial or by the way you walk, and they authenticate you. And this has to be done 3D so that you cannot like hold up a picture and say, I can hold up Jimmy's picture and say, I'm Jimmy. So authentication is done in real time and integrated seamlessly into the backend database, and information is pulled out. So in this scenario, information is displayed to who needs to see, and authentication is done, and there's a safety and security property as well. So that's a very interesting thing for healthcare. There's also, this is one of the things, the slide quality is so sorry. So I've been talking to a large manufacturing company. So they, as a manufacturing, they have plants, right? Workers who are not tied to a desk, not like us who are knowledge workers. So these workers come in and they badge in, they badge out, and based on the number of hours they're in the plant, they get paid. So their CISO told me that they actually did a study and they saw they have 5 to 10% of badge in fraud. So people take 2 badges, they'll swap in for their buddy, and the next day their buddy will do it for them. So 5 to 10% fraud, which really translates to financial loss, right? So they have to pay these people based on the hour because the badge reader says so, but they're not getting the productivity. And at a plant which has, for that company, they have over 30,000 factory workers. So that's a lot of money to be losing. So they're looking at what can we do to improve the precision of just that one workflow, which is badge in and badge out. And so they tried, they thought about doing fingerprinting, but that doesn't work because some of their workers are not documented. So fingerprinting, those people don't want it. They don't want a fingerprint. And so the way they now narrowed in on is facial recognition. And the facial data is stored in a privacy-forward manner so that the users can control what application sees it, what application gets to see what aspect of the information. So facial recognition, but is integrated in real time directly with the turnstile. So you walk in and you actually purposely put your face in front of an iPad because that's the intent. The intent that you are being authenticated. And once your face is recognized, it automatically opens the turnstile and you walk in, and then the back end records the time of the day you walk in, And then that integrates with the payroll system. So everything is done automatically. And they have experimented this in one of their plants. And the CISO said, yes, we're pretty sure based on preliminary data, that's going to reduce the fraud rate. So that's, again, it's a facial recognition, but it's really a positive business outcome because it helps you decrease fraud and improve productivity. So that's in the manufacturing space. And going back to the oil and gas industry, because I became a board member, so I started looking into the operations of that industry a little bit more. And there was a company that I was looking at. They have pipeline, natural gas pipeline that's 4,000 miles long, right? I think coming from Canada all the way to South Dakota. So it used to be the case that someone has to physically go to different points of the pipeline, and they have this contraption that looks like a disc, and you like dip into, there's a specific openings that are constructed along the pipeline. So you dip the disc into it, and then you pull it up, and it registers the natural gas compound. And then they can do tests to see if it has the right composition of different chemicals, and the pressure and everything can be measured by dipping this physical disc into the pipeline. Guess how long does it take them to walk the whole 4,000, not walk, but get the whole 4,000 miles of pipeline? It takes a year, a whole year, right, to physically dip those discs and record. And sure enough, this company had a problem. One of the places they had a leak, and they didn't know they had a leak right there. And I think, depending on how you look upstream or downstream, they kept pushing the compound over because they detect the pressure was low, and they thought downstream they're using it. They thought there's more use, so they kept pushing more, and it really polluted the place where the pipeline was running. Right? So, and that was a big PR problem for the company, and obviously it was not good for the environment. So today, and this was many years ago, today all the pipeline operating companies are installing smart meters, right, along the way. And you can't see really well, but this is on the bottom right is actually a picture of a control room, of a pipeline operating control room. So it kind of looks like a security operations center. They've got all the stats that display along the pipeline, and you can, anytime you can click into it to a particular smart meter to see what the pressure is, what the compound makeup is, and it's really interesting. And at any point, things go out of whack, you'll see alarm beeping, and they can send out someone right away to see what's going on. Now, that's a really interesting going from physical to digital. And some of the more cutting-edge companies are even thinking about automated controls along the pipeline where if you detect, so I'm just also still learning these, there's a particular composition of different chemical you want in the natural gas material that's coming through. And sometimes there's a particular harmful gas could build up. If it builds up too much, you want to release the pressure before you send it downstream, because that is it's harmful to the users down there. So today, most of the pipeline operating companies they can detect it from the smart meter, but to release the pressure, they still have to send someone there and physically open up a valve, because that's how they're operating. But some of the experiments people are running is remotely operating those valves so that you can release pressure in real time. You don't have to send someone to the field. Now think about a thousands of miles long pipeline. You got smart meters reading information. You got smart controllers that is controlling the flow of the gas. That is a whole digital infrastructure you have to manage and control and secure. Okay, so that's a long time to be setting things up. And digital transformation, okay, now this is it gonna work? Could be a win in your sale, but it could also be daunting if you're not doing it if you're not doing it well. It could be. Let's see, embedded video works. This one is taking me to a different, but it's not projecting, huh? Can you get, no, it's not working. All right, this is a problem of me working in Google Slides and then downloading in PPT and send it over. I would much rather just access in Google Slides directly. But this video is a sailing video, and one guy was just standing there, and the sail just came over and hit him in the face, and he dropped in the ocean. So if you're not doing it carefully, it could become a problem. Digital transformation is a huge topic. Now, I choose to focus on DevOps because that's what I see is when you start those digital infrastructure projects, be that cloud, be that consumer-facing workloads, at some point your developers are moving to a DevOps method because that's the only way you can sustain the rate of innovation. So today, if you think about the transformation journey in IT infrastructure as opposed to some of the OT things I talked about, in infrastructure, we have moved from like physical servers on racks to virtual to cloud, now to containers and serverless, right? So that's the infrastructure journey that we're on as an industry. And in the same way, applications and application software delivery is also going through a transformation. So we go from monolithic applications to multi-tiered applications. You've got a web, you've got application, you've got database, to software service, and now to microservices. And that's the application architecture transformation journey that we're on. And the delivery model has gone from, if it's a monolithic application, then it's major releases, right? Once, twice a year. And I remember Microsoft used to do that. Twice a year. And then you move to more agile. They're like, oh, maybe we released every 2 months. But today, continuous delivery is what most sophisticated software shops do. Jimmy, how many deployments a day do you guys do?
Unlimited, over 1,000.
Over 1,000. So that's Netflix. Is Netflix DVD or Netflix in as a whole?
As a whole.
Yeah, 1,000 times push updates to their applications. That's what continuous delivery, continuous integration is about. And that's such a different world than major release once, twice a year. And that's what DevOps is about, is be super agile and being able to do micro control of a software component and update it, manage it. Oh God, I'm not even going to go through the slides. But the way I see DevOps take hold is usually in the companies, there's grassroots effort of a few individual champions say, hey, let's download Docker, let's try it out. But it's not official. They're trying it on an individual basis, on an individual team basis, and they're having fun. They're just trying to figure things out. And then they got a few more people involved, a few more teams. They started having unofficial meetups. I've seen that all the time. And they will be like, Kubernetes studying session, something like that. And that's going from individual champions to grassroots campaign. And then at some point, senior development or management got involved, and they said, hey, this seems like a good thing. Maybe we'll bless an official project. And that's how official DevOps started in lots of companies. And in the end, hopefully, you actually have official budget allocation to certain projects. And this is a cloud-first development. This is a container development. And that became really how the company transforms. I am going to go through the transformation journey of 3 different companies. They look very different industries, and see how DevOps really made a difference to all 3 companies. I'm going to start with Target. As you guys know, Target's huge. They had, 2014 was the year Target started saying, okay, we need to really move fast at the speed of business. And they started from Target.com. Now, Target as a business, it's Fortune 39 on the Fortune 500 list. And they have, guess how many Target stores around the world? You can't read, sorry. That's encrypted. I think latest counts 1,800 stores. 1,800 stores, and during the holiday season, every holiday season, the entire Target adds, how many? Adds 70,000 temp workers. 70,000 workers into the stores and to take the increased holiday shopping volume. It's about 200 million store transactions per month during those holiday seasons. So as you know, it's a huge operation. And the challenge at 2014, at the end of 2014, they got a new CIO. And this person came on, I think he officially joined 2015, but 2014 was the time that he started looking at what Target is doing internally, and they're hugely monolithic, right? So there's no APIs, there's very little cloud type of development, and very little DevOps, although they did have individual champions in the within the Target development team that's trying out Docker and trying out Kubernetes, but it's not official projects. And at that time, I remember seeing a talk, and he said, if you are developing a new application and you need to put in the application the locations of Target stores, it takes 6 months. It takes 6 months for someone to actually find out where all the location is and hard code it into the application. Because there's no way to pull it from APIs. And then he said, when he found that out, he said, 6 months just to get store locations? He's like, nah, that's not the speed of business we're moving. We have to move faster. So he started a top-down mandate that all new applications that developed from that point on has to be cloud first, has to be microservices oriented. And just like, you probably remember Jeff Bezos wrote a famous memo of everything you develop has to be a service. And that's what he mandated, is all the functions that you develop from now on has to be a service, and the traditional application has to eventually migrate into all service-oriented architecture. So at that time, also when you get a software project, you're done, you test it, and you're ready to deploy, guess how long it takes from the end of development to actual operational? It takes 4 weeks to just onboard an application. It just sits there until someone gets the ducks in a row, and then you get it deployed, right? So that's 2014. And so when the CIO came, the beginning of 2015, started pushing cloud-first development mindset, they started in 2015, they started small. They started with 5 APIs. They said, okay, let's start with one project with 5 APIs, and let's see how it works. And they started doing their first CI pipeline. They experimented with the first one, and at that time, again, it started with app onboarding, 4 weeks, 30 days. Then so 6 months later, it's about 2016, mid-2016, or early to mid-2016, they started having official DevOps meetups, communities inside Target. They started, some of the more sophisticated developers started teaching classes how to develop using Docker, using containers. And they started, the senior engineers started identifying friction points of traditional waterfall model move to DevOps, and what are the friction points within this shift, and started working with management to remove those friction points. And by, I think, June 2016, the statistics is they started doing 10 deployments a week. And for Target, that's pretty good from like little over 6 months. Went from like major release to 10 deployments a week. And then by the end of 2016, early 2017, they had Target.com, that is, had about 30 APIs, and they were doing 80 deployments a week. So 80 times new codes being pushed to Target.com, and then they reduced, guess what? They reduced 30-day onboarding, app onboarding to 5 days. So, and this is what the CIO had documented is specific business metric, right? Onboarding time reduced from 30 days to 5 days. That's speed of business, right? So you get more new functionality to the website faster. And one of the things he credited as a really big enabler is they started these DevOps dojos. And they have these immersive course, 6-week immersive course that is done by a DevOps expert, either internal or externally they brought in. And they required all developers to, at some point, go through the training of DevOps Dojo. And this is really, the head of engineering also gave a talk at DevOps Enterprise, and she said that really changed the mindset of developers who have been long time coding in waterfall model. Right? So they go through this intensive training, 6 weeks, and when they come out of it, they can at least thinking about software development in a different way. So that is 27, and by sort of deep into 2017, they had several hundred APIs going, and most of the new development is service-oriented, service-based. They were doing 90 to 100 deployments a day to Target.com, and what to me was really interesting is their API traffic, going from no API in like the end of 2014 to 2017 is they have 40 terabytes of API traffic a month documented. That 40 terabytes, it's amazing. And the app onboarding, guess, it's down to minutes. Right? Once you're done testing, you went through the CD pipeline, it's minutes, it's operational. So that is business impact for you. That's Target, really huge company. And I'm going to talk about a different company. It's a fintech startup it's not a small startup anymore in San Francisco. It has very different makeup of infrastructure because they grew up in the cloud. This company has most of their workloads and infrastructure in AWS. And they are very much API driven, Microsoft and microservices and container heavy. But one of the things they realized at some point, this study was done in 2018, that they had multiple tech stacks, right? Every development team has their own choice of pipelines or even container formats. And so different tech stacks that just grew up organically within the company, and nobody's sort of managing or oversight. And DevOps is the king, of the company. And I don't know how much you guys work with DevOps team. They kind of, they think of themselves as the crown jewel of the engineering team, right? So I don't know if you've been to a DevOps conference, and they have those spirit animal T-shirts. My spirit animal is blah, and but they're serious about it. It's not that they're making a joke. They're serious about it, and they think of themselves as the unicorn of the company. And guess what? What do you know what they call security? Well, kind of, but the analogy is unicorn. When you remove the horn, is what horse. So they call security horse. But anyway, so that was the mindset internally, and nobody wants to do anything security related. And so then the new CISO came on board, and he realized that they were just running fast and loose, and a ton of new functionalities being delivered without security, proper security checkpoints. And he realized they have a ton of vulnerabilities that is just out there. And he said, okay, what can I do as a starting point to start building security into this environment, but not creating more friction between the security team and DevOps team, because they already are going head to head on a lot of things. So he decided he needs to pick his battle. And the one battle that his management had sanctioned is they want him to do a better job at vulnerability management, because nobody wants vulnerable code out there, right? Everybody can agree that's a good thing to do. So he said, okay, but what are the contexts so I can make decisions? So the context or the requirements is that dev teams must be allowed their own tool chain. You cannot come in and say, thou shalt use this stack. That's not going to work. He said, okay, so they're going to hold on to their own tools, and I'm not going to change that. Another thing is to a large extent, the development process must be respected. He can't come in and say, oh, we have to change, we'll change all the process. That's not going to work. So what his team did was, you can't read this, but every development team gets to have, still have their own development stack, their CI and everything. But the security team implemented a central CI. And that workload is triggered automatically when a specific dev team checked something into the registry, and then it triggered the security. There's a cron job just come into the Git and copies the code over into the central CI, then start a scanning process within that pipeline. And then if it passes the scan process, they put into a brown registry. And that brown registry then goes back actually to the development team, and the development team manages that. The repos in the brown registry then goes through the integrated testing, everything, and if that passes, then goes to the gold registry and then gets deployed. Now, if the security test doesn't pass, if the code doesn't pass the security test, then it gets pushed back to the team CI, say, hey, you have to take a look at this again. So what they have done is the CISO's team said, we're going to take control of a certain step within the entire sort of pipeline. But the team A, you get to have whatever tool you want. You just do your thing. But at some strategic points, we have automatic integration that just sucks code in, and we do our checks. Then we tell you what is going on. So what he did right is he let developers have freedom of use, right, and ease of use, meaning that didn't change their tools. They also supported whatever tech stack they had, but he enforced one thing: is the central CI has the authority to fail deployment if you don't pass the tests, and he got that to be an accepted norm within the company. And another thing he did, which was interesting, is they implemented a capability to tag repos, so that the minute that a developer checks in the registry a repo, it's tagged, and then it moves through the central CI pipeline, comes back, and it's all tagged, so that they can trace who checked in which repo and with what vulnerabilities attached to it. Now, this information, they only pull it out when they need to fight a battle, but the information is there. So at some point, it also became a weapon, if you will, to argue for the existence of the security process. So they were able to show that vulnerabilities are decreasing, and able to show that certain problematic developers are actually doing things better because they started seeing actionable results coming back. So this is a simple, small project they did, but really helped that company. Now, today they're different. They're doing a lot more things in security, but that was the starting point. And lessons learned is automation is critical. You can't demand your developers code things for you. You have to do it for them and make it really easy for security to be embedded in the pipeline. And also, they listened what the businesses wanted them to do and what are the bottom line requirements they cannot breach. One more question, one more case study. This is a media tech company, also in Silicon Valley. The company started, again, the product security team started a few years ago, and they saw a very challenging security dev relationship and very siloed operational model. And one of the big the complaint they got was static analysis was a big friction point. They were running, I'm not going to say the name of the tool, but the tool was generating a ton of false positives, and also the tool is like taking time to run and are stopping critical development tasks. So and speed to market is a big challenge. So the product security team looked at the incentives, the app dev and the security testing team, and to some extent the operation team is what incentives they have. The app dev is incentivized on the volume of features they develop by a certain date, right? The more features you push, the higher your bonus goes up. The security testing team is incentivized by the number of bugs they find. The more bugs you find, your bonus goes up. Guess what? Those two, it doesn't take rocket scientists to know that those incentives do not align, right? And especially when development project gets delayed a little bit, they seem like they're not going to meet their deadline, and the application team would work overtime, and they're tired, and they're producing more buggy code. But they don't care because they're not gold on buggy code. They gold on what features they push out. And then they throw it over the wall, and the testing team, the security testing team say, hooray, we found all these bugs. So that just doesn't work. So they said, okay, we got to change the incentives, right? But some of the realization they did is the product security team said, okay, they realized that the app dev team really is the one who knows the application the best. They should be doing more security tasks than they are doing now. The security testing team some of them don't know the application really well. So they had cases of security telling Node.js developers a JavaScript error, say you have to fix it, you have to fix this. And the developer's like, why are you telling me this? I'm a Node developer. But the testing team didn't know who was doing what. So that kind of thing got to be fixed. And they also found that it was easier to talk about artifacts than to talk about line of code. Because in that environment, in the DevOps heavy environment, the developers really want to be pulling down open source components and maybe do a little bit of node development and then push everything together. And they really want to think about things as an artifact rather than lines of code, which was the static analysis tool was trying to get them focused on, right? So, and they also realized that if you talk about security flaws as defects, really think about as defects and talk about as defects, developers actually have an easier time listening to you. So this is what they did. They did 3 steps, and they essentially shelved the static analysis product. Now, I'm not standing up here to say, don't do static analysis. I'm saying in that particular environment, at that point in time, was the right thing to do. They shelved the static analysis product. They brought in an open source fuzzer and made it so that the fuzzer can be triggered. I can't read. How many minutes we have? 10 minutes. They made it so that the open source fuzzer can be triggered by individual developers. And they also made that into a mandate that when you write your code, in the end, you have to write a fuzzing target along when you check in the code. So when you check in the code, the fuzzing tests are run automatically. And that took a little bit of time to implement. But after a while, developers all kind of bought into this notion that I have to specify my fuzzing target, and that is part of the check-in procedure. And then fuzzing is done every time new code is checked in. And they also brought in tools to focus on security component analysis, so that to look at the package level, when you are putting things into image, is there certain libraries that having vulnerabilities, the known vulnerabilities, instead of digging deeper into the code, and then trying to put together checkpoints along the pipeline so that highly vulnerable packages don't get deeper into the pipeline and eventually get deployed. So I call it reshuffled decks, so sort of they realign incentives, right? So there's a line there. Before the line are development, and after line is kind of a after the artifact's been created. And fuzzing test and specification of fuzzing test is part of creating artifacts. And after the line is all the analysis go into at the artifact level, but it's done automatically. It's done very, very quickly. Within minutes, the analysis is done. And then they have a deployment gateway, which based on the result of the analysis can automatically say, okay, this artifact gets deployed, that artifact doesn't get deployed. And once they implement that, their security testing team actually now didn't have a lot to do because everybody's fuzzing on its own. And they were like, what do we do now? And they actually started writing more tools to support embedding more security functionality into the pipeline, which is the team actually were happy to do it because then they don't have to deal with the friction between this is a bug, no, this is not a bug, this is a flaw, no, this is not a flaw. So that reshuffling of cards really enable them to build security into. So anyway, so the one thing I want to say is what they did is between app dev and ops, they really put a set of automation to make that happen. Okay, takeaways. Some of the industry trends I'm seeing, large companies are really kind of moving away from traditional AppSec tools. They're adopting more developer-friendly, more real-time tools you can use. And fuzzing is actually coming up as a very, very interesting tool people are using. Google has 28,000 computer cores doing fuzzing 24/7. So, in Google, this is already done as a culture that every developer fuzzes their own code. And you've got all these cores within the company. You can just upload your code and fuzz it. Cloudflare, they also are deploying developer-based fuzzing tools. They said, we're going away from static analysis. We are going to go deeper in fuzzing and support fuzzing workloads as an application security measure. And they brought in tools that are developer can run, developer can leave it running, developer can interpret the results, as opposed to tools that are developed by security team and for security guys. Microsoft has a mandate that every piece of code gets checked in, have to run 200,000 fuzzing tests, and have to pass the tests for 200,000 tests, and had to be without high vulnerabilities for at least 24 hours before you can officially check it. So it's a trend. It's an interesting trend to watch in terms of how AppSec's being built into pipeline. And also another trend is focusing on artifacts. I already said that. A little bit less on code. I don't know if you heard that GitHub. Okay, GitHub just released a package registry, which actually has basically it's a utility to keep track of your package and tell you what vulnerabilities and the lineage, everything, and it goes with it. It goes with them, meaning that even if you update, the knowledge is still there, and that's a pretty interesting thing. Automate and self-service. So self-service meaning that the more developers can do by themselves, micro-control functionalities and things that developer-friendly are the way to go. Okay, the end. I'm told to wrap up. Digital transformation start at a single starting point, and so does DevOps. Right? Start small, one project, one package at a time, and really think about what kind of win you can get in your environment. It could be a very small step, but as long as you're accumulating wins along the way, you'll get to a successful stage. And another thing I can't stress enough is identify where things are complex and remove complexity. Complexity is the enemy of security. It is enemy of scale. And also do automation at meaningful places. Find where really human adds value and say, okay, this is a place human adds value. Let's do that, but automate everything else. So with that, I'm going to wrap up. Thank you.